All right, Algebra 2, here's part 3 of our completing the square discussion. Let's go ahead and do one more example. Let's go ahead and use the steps we came up with to do part C. So first step, separate C from ax squared plus bx. So now separate can actually have a dual meaning. If you remember from part B, I went ahead and just separated it from from y squared minus 12y by just kind of pushing it to the side. I don't want to talk to you right now. I got to deal with my drama first. I got to deal with my completing the square drama, and then I'll talk to you plus 4, right? Now, if you notice, that's already kind of naturally separated. This 22 should be over here. It should be minus 22 on this left-hand side, but it's already on the other side of the equal sign. So let's go ahead and just leave it there. It's already separated. We don't need it to be on the same side. That 22, we could very well move it back if we wanted to, or we can keep it there, right? And so that tells us a little bit about the one we just did. I could have either, pushed the 4 to the side, or I could have just subtracted it over to the right altogether. Whatever you want to do, whatever makes more sense to you, okay? So it's already over there, let's leave it there. Step 2 was to factor out a GCF from ax squared plus bx if possible. So here's our ax squared plus bx. Is there a GCF? Yeah, there's 2. What happens when we factor it out? We get 2x squared plus 6x. And remember, we still want to leave room here because that's what we're going to add to get our perfect square trinomial, equals 22. All right, so now step 3 is to calculate that b over 2 squared and then add it to the ax squared plus bx. So what's our b over 2? Notice that we're not using our original b, we're using this new b, okay, after we take out the GCF. So 6 divided by 2 squared is 3 squared, which is 9. So plus 9. Now, normally I got to balance by subtracting on the same side, but I'm not just going to subtract 9. I'm going to subtract 9 times 2, because whatever I do on the inside, I'm multiplying that by 2. So I actually did not just add 9. I added 9 times 2. So if I add 9 times 2, I have to subtract 9 times 2. Okay, so let's see what we end up with. We get 2. I can factor this down to x plus 3 squared, right? Remember, it's always half of our middle term. Minus, what's 9 times 2? 18 equals 22. Okay, and now we can solve it like we usually have been. We got to get the squared thing by itself. Okay, so how do we do that? Well, we want the squared thing being this. Let's get that by itself. So let's add 18 first, plus 18. And then what do we get when we do that? We end up with, ooh, give me 1 second, guys. Nope, just kidding, we're good. So 22 plus 18, what is that? That's going to be 40. Then our next step is to get rid of this 2. Divide both sides by 2. We get x plus 3 squared is equal to 20. So now we go ahead and take the square root of both sides. Oh, sorry. I took the equal sign with me. I don't want to take the equal sign with me. I just want the 20. There we go. Plus minus. On the left-hand side, I'm left with x plus 3. On the right-hand side, I have plus minus square root of something. Well, 20, is there a perfect square that goes into 20? Yeah. 4 times 5. 4 goes into 20 and it's a perfect square. So I can rewrite this as plus minus 2 rad 5. X plus 3. Subtract 3 on both sides. I get x is equal to 3 negative 3 plus or minus 2 rad 5. And there's our answer. Okay, so notice how the way we completed the square here was a little different, right? I still followed all those steps from above. I kind of stopped going along with them, but the balance, when we balance, that also takes into account this 9 times 2 that we did. In order to properly balance this equation, I did not want to just subtract 9. I had to take into account that this 9 is technically being multiplied by the 2. So I didn't just add 9, I added 9 times 2. So that's why I had to subtract 9 times 2. Okay, let's see another example of that in a different context. Okay, we can also use completing the square to take a quadratic function in standard form and rewrite it into vertex form. So let's see how we can do that. Let's rewrite the following quadratic function. Sorry, I didn't mean to put functions. Function into vertex form. And then once we have it in vertex form, let's identify the vertex. Okay, we don't always need an equation. We can have a function to complete the square. So let's see how we do that. Remember, our first step was to separate away the c. In this case, we're gonna have to leave it on the same side. All right, so negative 3x squared minus 12, oh, that should be an x right there, 12x plus something minus 9. Step 2, that was to factor out a GCF. Do we have a GCF here? Yes. It's not just 3, it's negative 3. So let's factor out a negative 3. Okay, what are we left with on the inside? X squared plus 4x plus this mystery number minus 9. All right, let's do that b over 2 squared. So 4 over 2 squared equals 2 squared, which is equal to 4. So plus 4. And now here's where you got to be extra careful. We're going to balance by subtracting 4, but not just 4. It's 4 being multiplied by this negative 3. So minus 4 times negative 3. I get negative 3. I can factor this into x plus 2 squared. And I get negative 9. This becomes plus 12. Negative 9 plus 12, that's going to be positive 3. So my function in vertex form is negative 3 x plus 2 squared plus 3. Okay, so that's how we can go from standard form, which is what we have here, to vertex form, which is what we have here, right? In previous sections, we knew how to go from here, from our vertex form to our standard form, right? By squaring this out and then distributing the negative 3 and then adding the 3 to our like term. But now we know how to go both ways, okay? What's our vertex? Well, we're in vertex form, so it's our hk. Our h is negative 2 and our k is 3. So our vertex is negative 2, comma 3. All right? So that's how completing the square can help us in 2 different ways. It can help us solve quadratic equations. It can also help us write things into vertex form. Awesome. Let's do one more example. Let's see how this helps us in an application problem. The height y in feet of a baseball t seconds after being hit is given by this function. Rewrite this function in vertex form, then use the new function to find the maximum height of the baseball and how long it takes to reach this maximum height. Okay, we're looking for max height, so that tells you that we're looking for the vertex. Well, let's kind of talk about this for a little bit. In the past, we've done something like this before, where we didn't have to rewrite it in vertex form, but we knew how to find the vertex, right? We could have used negative b over 2a and then plug that in to get the y value, right? So let's see how we can do this using completing the square instead of that negative b over 2a stuff, okay? So what was our first step? Separate out the c term, that 3. So I get negative 16t squared plus 96t, sorry, plus our magic number, plus 3 on the outside. Then our second step was, do we have a GCF here? Well, we do if we can divide 96 by 16 or some factor of 16. Can we? Yes, 96 divided by 16 is actually 6. So let's factor out this negative 16. I get negative 16 t squared minus 6t plus our magic number plus 3. All right, so b over 2 squared, negative 6 over 2 squared, oops, sorry, is negative 3 squared is 9. So plus 9. How do we balance? Remember, it's minus 9 times our a, minus 16. So that ends up being 9 times 16 is 144, so plus 144. Okay, so negative 16. This factors to t minus 3 squared. 3 plus 144 is 147. And here is our new function. This is the same thing as this. They're equal, but they look different, right? They're the same thing mathematically, but notice that this one tells us different information from the one we just found. Could I immediately get the vertex from this one? No, I would have to do negative b over 2a to find it, right? But I do know the y-intercept is 3. I can get the vertex from here, but I couldn't tell you what the, sorry, I drew a blank. I could not tell you what the y-intercept is from this one, right? Because there's no indication of the y-intercept here unless I plug in 0 to actually calculate it. I don't see it immediately. That's the difference. I see different things immediately from each of these. All right. So now what's our maximum height and how long does it take to reach the maximum height? Well, that means we're looking for the vertex. And we know our vertex is 3, 147. Okay. Our 3 is the t and our 147 is the y. So we know since y is the height, we know 147 is the max height. 147 feet. And then time it takes to get there is the 3 seconds. All right. Hopefully that sounds okay to you guys. Definitely rewatch these videos if completing the square is completely like, I don't know what you're talking about, Mr. G. Otherwise, we will also go over it in class, okay? I will see you in the next section.